Thank you so much for being here. And welcome to the talk on OpenID for Verifiable Credentials. The work is done in OpenID Foundation, but it is done in liaison with DIF, Decentralized Identity Foundation, and ISO, SC17, Working Group 4 and Working Group 10, which is where MDL, 18013 Part 5, and mobile EID document-related specifications are being worked on. So we have a really good group of people working on these specifications. My name is Christina. I work in identity standards at Microsoft, and I'm honored to co-present with...
Hi, I'm Thorsten Lodderstedt. Great to be here. Thanks for you for joining our session. I'm CTO of yes.com. We are a commercial open banking ecosystem, and I've been contributing to identity standards for quite some time. And I'm really excited to work with a lot of people in different organizations on this new protocol for issuing and presenting verifiable credentials. Verifiable credentials are a new paradigm in identity. And as we learned today in the keynote by Yves Mailer, it's a trend, right? Verifiable credentials are basically sets of claims that have a cryptographically verifiable authorship, and they are tamper evident. You might think, well, what's the difference to SAML assertions or ID tokens or other kinds of identity assertions? And the main fundamental difference is the way those assertions are being handled and exchanged between the different parties. While in classical federated identity systems, the assertion is sent from the party controlling and issuing the stuff, identity provider, or OP, is directly sent to the consuming party. In the case of a verifiable credential, that credential is issued to the user, holder, maybe stored, and then at the discretion of the user, used, it's called presentation, at different places. So there is much more control from a user standpoint about where and when those identity assertions are going to be presented. That also causes a lot of security challenges that we need to cope with, but there are solutions for that. So first of all, it decouples the issuance of identity assertions from the presentation of identity assertions. And it allows to present the same credential that is controlled by the user multiple times, wherever the user wants. And it also allows to combine credentials from different sources, which opens up a whole new cosmos of use cases, what you can do with this kind of assertions. As Yves pointed out, it's not necessarily only about identity. It's generally about attestation of data that then can be combined, meshed up, and so on. And verifiable credentials are out there, right? So just a couple of examples on the slide. So the mobile driver's license, for example, is being rolled out across the United States as we are speaking. And the COVID certificate, the vaccination certificate that we now are all used to use, is also a credential in the end. So you already realize there are a couple of different formats of those credentials, which is part of the challenge we have to cope with. Sorry, that was too fast. So the advantages and the benefits of verifiable credentials are manifold. To just pick some, users have more control about the data. And it's more privacy preserving because, for example, the issuer doesn't know where a credential is going to be used and when. And also, credentials can be ported from one place to another. And if we open up the scope, in the end, you can digitize any kind of physical credential, which makes identification faster, cheaper, and potentially also more secure. And the third point, and that's really what makes me really excited about that topic, is with digital credentials, we now have an approach in our hands that is universal across the digital and the physical space. So with the credentials on my phone, and we've seen it in the keynote yesterday, you can address the needs of use cases in both spaces in a seamless manner. And this is really, that's potential. But also from the issuer's perspective, there is more flexibility in that game because verifiable credentials need to be presented in a couple of different channels because we want to use them in digital physical space, right? So this is not just about web SSO. It's not just about HTTPS. It's about near-field communication. You want to use that to open the door, to unlock a car, to pay someplace else. So a lot of things that you need to implement, but the issuer doesn't need to take care of that. Instead, it's the wallet that has to take care of that. And the wallet is also getting kind of a marketplace, right? Which allows issuers to perhaps monetize their credentials. So a lot of flexibility, a lot of potential. What we have done at OpenID Foundation in cooperation with DIF and ISO, we have developed a set of protocols that sit on top of OAuth 2 and OpenID Connect that allow the implementation of the two different interfaces that exist in that conceptual model. On the left-hand side, it's the interface between the issuer and the holder that is used to issue verifiable credentials. That's where we have the OpenID for credential issuance specification for. And on the right-hand side, we've got two specifications because we distinguish the presentation of a credential, which is OpenID for verifiable presentation, and the authentication using a pseudonymous identifier with a verifier. And that's why we use self-issued OP version 2.4. You might ask yourself, well, why the heck do they use OpenID Connect for that, or OAuth? It's so boring. Well, the reason is because it's boring, because it's out there. There is deployment experience, there is security analysis, there is tooling. It's just freaking simple to implement, right? And this is key for adoption. Because we are talking about millions of applications need to implement, incorporate verifiable credentials. So you can't really assume that a super complicated, sophisticated protocol is what you can use for that. And by the way, OpenID Connect back then, when it was published in 2012, really has foreseen the idea of an OpenID OP that resides on the phone of the user. The concept was called SIOP, self-issued OP. And we thought it would be a good idea to use that as a starting point, right? And also, as I said, there is a lot of deployment experience today. So there are relying parties that use OpenID Connect. There are OPs that use OpenID Connect. And with the protocol suite that we have defined, those can be extended in a more easier fashion to also utilize and incorporate verifiable credentials. And with that, I'm handing over to Christina.
Thank you. I will talk to the right-hand side you just saw, a relationship between the holders, a wallet, and the verifier, so presentation side of the hand, right? OpenID for verifiable presentations is where we will start. And at first, I want to guide you through the user experience, how the user flow would look like. Two flows, same device and cross-device. So same device flow, everything starts and ends on one device. On my phone, let's say phone, mobile phone, I go to the verifier.com. I want to get access to some service. In this case, I want to register somewhere. Authentication, fingerprint, could be something else. Because in the request, verifier requested me to present a certain credential, I see a prompt. Do you trust this verifier? Are you sure you want to present this credential? If I do, I would click yes. Credential will be sent back to the verifier. Success, I get access to services, great. Pretty basic flow, right? This might be new to you, a cross-device flow, where device where you start the interaction and device on which you have credentials stored is different. So imagine two devices, desktop and smartphone. You start on your desktop, you open a browser, you go to verifier.com. Again, you want to access some resources. In this case, you want to register. Instead of clicking a deep link, I see a QR code. I take out my phone, second device. I scan that QR code with my phone. That QR code contains a request. The PIN is authentication, what you saw as a fingerprint in the previous slide, yeah? I authenticate. Again, the QR code contains a request to present a certain credential. Do I consent? Yes. Credential is being sent back to the relying party who were started on the desktop. So my desktop in front of me refreshes, and I continue shopping, accessing whatever I want on the desktop. I can put back my phone in my pocket, yeah? So then how do we realize this user experience using the protocols? Conceptually, it's fairly simple, what I just already walked you through. User wants to access a certain resource, verifier sends a request, give me this credential, and the wallet sends back a verifiable credential, signed using user's key as a verifiable presentation, as Torsten just explained. This is built on OAuth 2.0, and what we extended are these 3 points. So first is a mechanism how verifier can specify in detail what they want the user to present. What kind of credential, which format, what cryptography, or what claims within the credential I want. Maybe send me only first name, last name, but don't send me date of birth. Or send me a credential issued by an issuer who belongs to this federation, but not that federation, for example. Request. In the response, we defined a new artifact called VP token. Not ID token, not access token, VP token. So there's clear separation of concerns and separation of actually what is being returned. And the set conceptually is similar conceptually simple because one way to do it is simple request response, where credentials are stored locally on the wallet. But maybe you have a requirement where a wallet can have a cloud-based component, a backend, right? So there's also an option to return data, the actual credential, from server to server, from wallet's backend to a verifier, or return a credential directly through a redirect using the user agent. So this is conceptually how we extended the OAuth, which you would already have libraries for, experience for. And our core philosophy when designing this has been enable choices throughout the components within the verifiable credentials tech stack. As you know, there are a lot of credential formats, a lot of entity identifiers, how you can get keys, different crypto suites emerging, verification mechanisms, trust framework, you name it. We want to enable your choice, but my pitch has been, let's at least make sure you and I can talk. That wallet and verifier can transport, we don't know what yet, we may change what we send, but let's make sure we can transport. So if you have a credential format or an identifier type that you read a spec and you think it's not supported, let us know. We'll make the best effort we can to support it. Have I said a term PSYOP until now in this presentation part? I have not, right? Probably you are used to associating self-issued OP with presenting verifiable credentials, but if you're thinking of implementing sending verifiable credentials, OpenID for verifiable presentations is a specification you would need. Please, that's one of the core take-back I want you to have. But PSYOP v2 is still really relevant to the space. How? Well, let me explain that part now. So OpenID for verifiable presentations is based on OAuth. Self-issued OP is still an extension of OpenID Connect because you can use it to authenticate the user. And what self-issued OP boils down to is a user's ability to send a subject-signed, user-signed, self-signed, self-issued ID token. Usual ID tokens you would receive from identity providers like Microsoft, Google, Yahoo, banks, whatnot. The ID token you would receive, the identifier of the user would be namespaced to the provider. It would mean this string, this collection of numbers and letters, are user's identifier within this identity provider, within Microsoft's database, right? So you can take it to different places, but here we're enabling the ability for user to say, this is me, right? It's not namespace to any provider. This is me. So this is the fundamental. And how we enable this? Again, a couple of points, right? I already explained first and second, so I'll focus on this third one. So by now you're wondering, when do I use OpenID for VPs? When do I just use PSYOP? When do I combine, right? And using on their own is fair use case. So if you only want to receive verifiable credential, use only OpenID for VCs. If you want to allow users to bring their own identifiers, use only sign-up v2. But there's also power in combining. A use case where when you interact with a user for the first time, you ask the user to send a self-issued ID token. You would use that as a user identifier. But you also ask the user to send driving license, house insurance card, whatnot. You make a decision based on that information, or you put that information into user account you just created. The second time, third time, you ask only self-issued ID token. So for the second, third, you only authenticate the user, same user, I know which data to pull, great. If you want to use step-up authentication, or you want additional information, you want to ask for employee information, you can again bring in OpenID for VP and ask the user to present an additional credential, right? So this is how you might want to fit in these two specifications within your use case. And a couple of very important points. First, so why you would want to use it, right, in these use cases. The first, it's format, crypto, all these components agnostic, as I have already explained, enables same device, cross-device, the first two user experience we have seen. It enables mutual authentication of verifier and wallet. So if you've been to my session before, you kind of ad hoc trust possible, but also, there are a lot of mechanisms that you can get information to see if you can trust the entity you're interacting with, metadata. Pseudonymous authentication to repeat, so this was a use case I just explained, works really well with OAuth for authorization, API-based payments. Thorsten knows a lot about this. We're working actively on offline scenarios where it's app-to-app and keys are pre-cached. You potentially would not need to touch the internet at all, and this is a requirement people have been telling us a lot. So if you have experience, please come talk to us. Selective disclosure is possible if the credential format you're transporting supports it. And one of the key components has been these specifications, both are being mentioned in MDL, mobile driving license, and MID, mobile EID document related specifications. So this vision where you use the same protocol to transport MDL and W3C verifiable credentials is technically there. Whether you implement it, we'll see. So, and if you're looking to implement, those specifications are in the first implementer's draft status, which means if you implement, you would have AIPR protection. So you will not have to worry about patents, right? And if you're looking to read, please make sure you read the latest drafts, because you've made some changes in the specification, so you would not want to look at older versions. And we're planning to go to second implementer's draft by the end of this year, so these two, you would look, the latest drafts should be fairly stable. And you have a lot of implementers already lined up, so if you want to try, if your implementation interoperates with them, can work with them, again, these are the companies you can reach out to. And now let's talk about issuance.
Thank you. So let's start with the user experience also. So we've got a couple of different kinds of user experience that you can provide your users with. That's a simple flow where the user visits your experience and then somehow is entitled to receive a credential, and you can issue that flow directly by redirecting the user to the wallet, right? That's happening on the same device, and then the device queries the credential, and the credential can be used going forward for presentations. Pretty simple flow. And the same is also possible if you wanna fetch the credential from a wallet that resides on your phone, and the device where you visited the issuer is on a different device, right? So we use a QR code here as well. You scan that QR code, and then the wallet from the other device can receive that credential. Please note, since in this scenario, it's a bit tricky because someone can try to steal your credential because QR codes can be copied, right? We also have additional security mechanisms to really make sure that the integrity and the security of the transaction is being preserved. And there's a third flow, which is very interesting and is pretty unique to our protocol design, because you can also, when the wallet receives a presentation request, just turn around and ask the issuer to issue a credential. Why do we think that is important? Because experience shows that users do not prepare for anything. Which means, if you want to present something at a site or an app, likelihood is very high that the necessary credentials are not present in the wallet. And in other approaches, that's a dead end, because then the user needs to go and find a place to get the credential and start the process again. We believe this is a much better user experience, because, as I said, based on the information in the request, you can determine, perhaps, what issue you could contact to get the credential, and then you turn around, run through the flow, receive the credential, and can use that for the first time to present it to the verifier. So this is all possible, and we came up with a pretty simple design. So what we did is we defined a new API. It's called the Credential endpoint, and that API is used to request and receive new credentials. And the authorization of that endpoint uses OAuth. So you can use, for example, an OAuth authorization code flow, but we also have introduced a new grant type for especially those cross-device scenarios. But you could also use the device code flow, CBA, and so on. So we are leveraging the whole family of standards that are out there in the OAuth specification world. And the API allows, based on an access token, to request the creation of a credential. And you can, for example, using the same access token, request the same credential in different formats, if that is necessary for your use case. The API also supports batch issuance of credentials, and you can also refresh credentials. So, for example, if you have a refresh token and your credential has expired, you just go back, get a new access token, and refresh the credential, which is the poor man's approach, right, to lifecycle management for credentials, but it works. Design principles, it's an OAuth protected endpoint, and we've got all the traditional flows, and we introduced a new grant type. It's called pre-authorized code flow, which can be used in situations where the user already run through the experience with the issuer, already is entitled for the credential, is already well known, so there is no need to go through the standard OAuth dance. We are ready and set, and then the issuer can directly issue that code that is then exchanged with the token endpoint. We really worked hard to make sure that the credential endpoint can use with scenarios that require high security levels. So there are methods for doing proof of possession for software-based keys, for hardware-based keys, and for different formats. And the approach also supports non-signature-based approaches that use blinded proofs or something like that. So it's really made for flexibility. And we are looking for implementation experience. So we have a couple of prototypes up and running with different credential formats. But if you're considering to go that way, please talk to us, because we would like to incorporate all the experience of the community in evolving the specification. So just to sum up, why do we think it's a good idea to use OpenID for verifiable credential issuance? First of all, it's credential format and crypto agnostic. Second, we've got attestation for all kinds of key material up until HSMs, TEs, and so on. You can use it in cross and same device scenarios. We also made sure that it is possible that the wallet, for example, and the issuer can authenticate to each other, which is key in regulated scenarios. So, for example, in the European Union, there is an update going on the eIDAS regulation for identity, and that regulation, for example, will require wallet providers to get an approval, to get an accreditation. So, as an issuer, you need to make sure you're talking to an accredited wallet provider, and we just use OAuth client authentication for that. That's as simple as it can be if you leverage existing standards. And what we're really also focused on was to make sure that existing OAuth and OpenID Connect deployments can be leveraged. So I had a conversation over lunch, and we came to the conclusion, well, there are a couple of OpenID implementations out there, and there are billions of identities out there. Wouldn't it be cool if those IDPs could be turned into credential issuers pretty easy? And that's one approach, right? Because you extend your OpenID implementation with a new scope or rich authorization details type. You set up a new endpoint, and you're good to go. And this issuance specification will also be part of an upcoming ISO specification. The status, we are heading for implementers draft. There are already existing prototypical implementation in the field or being planned. And if you're considering to implement that, please help us by providing feedback to us We have made super progress with the presentation spec. We are at the 12th revision right now after not even a year, which is due to the fact that we have gotten tremendous feedback from the community, and we incorporated that, and it helped us to make the specification more mature and even simpler.
So right now you're wondering how many QR codes you're going to see on the slides. This is the last one. If you're looking for a place, so you don't have to Google this presentation, that presentation, we have a white paper for you to help you, guide you through your decision-making process when using verifiable credentials. Some of popular sections so far: demystifying some myths about verifiable credentials, redefining decentralization, how the trust model is going to shift, if it's going to shift, business drivers, use cases. So it's a second editor's draft. We published a new version today morning. Feedback welcome. It's not the final version yet, so reach out to us if you have some concerns, questions. But so far, the feedback has been super, super, super positive. So please.
All right, we run out of time, so I will give the brief update. So why should you use this stuff? Well, it's based on the collective deployment and development experience of the OpenID and OAuth community. And adoption is underway in a couple of places. We would also like to notice that you can use that in really high security scenarios if you combine it, for example, with the FAPI security profile. And it provides you with interoperability on the protocol layer. No matter what credential formats you want to use, or you need to use, or you must use, even in combination, right? It at least gives you a bit of interoperability in that really emerging space.
Just a bit?
All right. Yeah, I think we already said that. Please implement the specification for your use cases and give us feedback. And the same for the white paper. Give us feedback on it and let us know if we somehow need to improve it. Thanks a lot.
Thank you.